NASA got a huge Christmas gift this morning when it successfully launched its most powerful space telescope ever.
So when we walk out under the stars and look above us, we're not seeing the stars as they are today.
Headlines are currently circulating on the internet that, to put it mildly, make us sit up and take notice. The James Webb Telescope is said to have identified a bright carpet of artificially generated city lights on Proxima b and, thus, to have provided the answer to what is arguably the oldest question of humankind. After all, in this case, we would clearly not be alone in the universe. But what is the true background to this groundbreaking claim? Can we already prepare ourselves to make contact with our extraterrestrial neighbors, or are we better advised to treat the sensational reports of our time with a healthy dose of skepticism? When we hear the buzzword extraterrestrials, we often think of highly intelligent creatures that possess futuristic technologies that we can't even begin to dream of. However, experts take a slightly different approach in their search for extraterrestrial life. It is by no means always exotic creatures that undertake one interstellar journey after another aboard high-tech spaceships. No, when it comes to life in general, the search for extraterrestrial bacteria, microorganisms, algae, and plants is just as important as the search for fully developed civilizations. No wonder, after all, as things stand, Earth is still the only known celestial body in the universe that has produced both. But if you like, we are also faced with a homemade mystery. We still have no idea why and how life on our blue home planet has unfolded and how it ultimately even managed to overcome the hurdle of intelligence. For billions of years, the Earth was home only to microorganisms, plants, and animals, and in the context of Earth's history, it is only a blink of an eye since one branch of life produced a species that is now capable of creating technological wonders like the James Webb Telescope. But despite all the most powerful space telescopes of all time, we cannot even clearly define what intelligent life basically is, not to mention the question of whether intelligent life beyond Earth even remotely resembles what we know. In the absence of comparable discoveries, however, we ourselves remain the only clue available to us in the search for our unknown neighbors. Accordingly, the search for extraterrestrial life always follows the question of which factors are necessary to pave the way for the flourishing of Earth-like life. And when it comes to humanity in particular, we can probably agree in principle that we are not friends of the dark. We have always fought the darkness of night, first with fire and later with electric light. Nowadays, our radiant traces are so pronounced that they can even be seen from space, and while the starry night sky used to unleash an overwhelming spectacle of light over our ancestors, in most cities it can often only be glimpsed today due to light pollution. With this in mind, and assuming that other civilizations in the cosmos have followed a similar path to ours, the question arises as to whether there are planets out there that shine just as artificially, and whether we would be able to recognize this at all. Could we see the city lights of alien bodies? Fortunately for us, we are not the only ones dealing with this topic. In fact, the question of alien technosignatures is anything but new in professional circles. A few years ago, Eliza Tabor of Stanford University and Harvard professor Avi Loeb once again wondered how realistic it would be to detect the telltale light trails of a nearby exoplanet as part of a research study. However, the experts' work was not based on just any nearby exoplanet, but on Proxima b, which lies at a distance of just 4.2 light-years, practically right on our doorstep. However, it should be noted at this point that this still corresponds to a considerable 37.8 trillion kilometers and that, with our current means, it would take several millennia to reach Proxima b. Fortunately for the two researchers, however, their theoretical considerations did not require them to venture into the vast expanses of space themselves. Assuming that this extrasolar world is actually graced by a highly developed alien civilization with brightly lit cities, could we see it? Well, the sobering answer is no, absolutely not. Well, at least not directly, because even the most powerful telescopes of our time would not be able to capture the hypothetical sea of lights directly on film. In the same breath, however, it is possible to approach the city lights of desire in a different way, because we can measure how much light the exoplanet reflects from its host star, Proxima Centauri. More precisely, we can predict the expected value within a certain range, and if the actual measurements exceed the theoretical predictions, this could be due to the artificial alien lighting. And what better instrument to detect this than the revolutionary James Webb Telescope? After all, Webb is up to 100 times more sensitive to electromagnetic waves than its scientific predecessor, Hubble, and in theory, it could even detect the heat of a bumblebee on the surface of the Moon from Earth. In practice, however, Webb has been providing us with spectacular images from space for over 2 years now, and in the process, it reminds us time and again of how much there is still for us to learn about the true character of the cosmos in the future. For example, there are the impossible galaxies detected by Webb, which, with their formation date a few 100 million years after the Big Bang, appear far too large and massive. Since some of the galactic premature babies were already as developed as our Milky Way is today, they have earned the inglorious nickname of universe crushers among researchers. Elsewhere, measurements by the James Webb Telescope have confirmed the so-called Hubble tension and shown that the universe is currently expanding much faster than our theories allow. It is obvious that the $10 billion device has the potential to shake our established assumptions. But what has Webb now discovered with regard to the artificial city lights of Proxima b? Well, nothing at all. A question of habitability. There is one thing we must not forget. When the corresponding study by Eliza Tabor and Avi Loeb was published on May 17, 2021, the James Webb Telescope had not yet been launched into space at all. It was not launched until December 25, 2021, and it took another 6 months before the public could marvel at the first Webb images. The headline stating that the James Webb Telescope has actually detected artificial city lights on Proxima b are, to put it mildly, somewhat generously interpreted. In truth, the two researchers focused only on the question of whether Webb would theoretically be able to make such a discovery. In reality, we don't even know whether life exists on Proxima b at all, let alone what technological advances it has already made there. What we do know, however, is that Proxima b is actually listed as a habitable world. After all, it orbits its parent star in the habitable zone, and thus at a distance that allows the existence of water in a permanently liquid form. And yet, the mere presence of the wet elixir of life is not enough. Other factors, such as the atmospheric conditions or the radiation from Proxima Centauri, could still thwart the plans of life despite all the favorable conditions. This brings us to a not insignificant point. Proxima b orbits its star at a distance of just 7 million kilometers. As a result, it takes just over 11 days for a complete orbit, and its surface is characterized by scorching heat, well, at least half of it. While Proxima Centauri is a red dwarf that only has about 12% of the mass of the Sun, the data collected so far suggests that Proxima b has a bound rotation. On the one hand, this means nothing more than that it always presents one and the same side to its parent star, and on the other hand, that as a result, its surface is divided into a bitterly cold night side and a significantly hotter day side. So, can we throw Tabor and Loeb's study in the bin anyway? After all, this extreme division seems to nip the idea of potential habitability in the bud. Well, we shouldn't be quite so hasty. There could actually be a narrow strip between the two zones that offers conditions conducive to life. Surprisingly, the sharp contrast could ultimately even favor the conditions in the so-called twilight zone. The expert simulations have shown that the habitable zone could obtain its liquid water supply from the glaciers on the night side. These would melt near the twilight zone, feeding the lakes and rivers. When will we be able to detect the city lights of Proxima b? So far, so theoretical. But the question of the habitability of Proxima b remains hotly debated. The skeptics point, among other things, to the turbulent activity of the host star. A few years ago, Proxima Centauri attracted attention with a radiation burst that was 100 times stronger than any solar flare observed so far. In the same breath, however, the exoplanet could have a stable magnetic field that shields it from the dangerous radiation of its host star, keeping the water molecules and oxygen on the planet. But let's assume the exciting case that all the factors favoring life on Proxima b interact, and a highly technical alien civilization actually thrives there. When would the James Webb Telescope be able to detect the artificial lighting? Well, the research results of Tabor and Loeb answer this question as follows. If the inhabitants of Proxima b use the same type of LEDs as we do, then the nighttime lighting there would have to be 500 times more intense than here for Webb to have any chance of detecting it. However, if the lighting intensity there is comparable to that on Earth, the extraterrestrial light would have to be distributed over a much narrower frequency range than here for there to be any possibility of detection. Assuming these admittedly very special conditions, Webb could catch a glimpse of the extraterrestrial city lights, if they really exist. That's a lot of subjunctives, and many an expert believes that we would be better advised in our search for life in space to continue to think outside the box on Earth. In other words, just because evolution on Earth has produced eyes that can perceive visible light, and thus also its absence at night, does not mean that this must also be the case on Proxima b. Because, who knows, maybe life there has no sense of electromagnetic wavelengths in the visible range, or maybe not even something that comes close to a sense of sight in any way. Perhaps the inhabitants there rely on sound waves or something completely different, and there is no reason for them to switch on artificial lights at all. We simply don't know. But isn't it sometimes the unknown that makes dealing with a topic so exciting? And if you want to make it exciting, just press the like and subscribe buttons without further ado, so you never miss a new video from us again. We'll see you soon.